Well, good morning. This is a bit of a interlude into the dumpster dive score. I wanted to take a quick break and show some work that I've been doing with my 8563E and DLPs, or downloadable programs, that you can stick on this device. So what I did, what I have on the back of that 8563E is a mass memory module. Now, these are very common. I think if you get the 8563, it comes with the mass memory module. So I think probably most of the 8560E series has that. And you can see sort of here's a textual drawing of the module. I can't show you because it's in my rack, and I'd have to pull the rack out to actually show you what it is. But you can see where it plugs into the back of the unit and has a little slot that you can put cards into. And those cards can have programs on them, and you can transfer them from the card onto the mass memory module itself. Now, the mass memory module is a battery backed up memory, and I stupidly forgot to change the battery when I got prompted for it. You know, one of those things, oh yeah, I've got to do it, but I'm not at home. I'll do it when I get back. And I forgot about it, and so the battery failed. So I lost my applications, and the two DLPs I had were the 85671A phase noise utility, which is a DLP that you can use the 8560 series scopes to spectrum analyzers to go and determine phase noise. Now, this one's not really that useful because KE5FX has a better phase noise utility that you can just download for free, and it will work against a bunch of different sources to do this, to grab the phase noise information and so on. The one that I did use quite a bit was the 85672A spurious response utility. This is a utility which measures spurs, harmonics, third order intercept, intermodulation products, and so on. And it was a good way of going and grabbing, just doing quick test on my signal generator. I could plug my the 8657B in, run the harmonic test. It could check that. I could run spurs. It could check that and go, okay, yep, we're running within spec, and not have to do a full calibration of the unit and so on. Now, having lost these items, I needed to put them back, and you can find every now and then the actual installation cards on eBay, but they're generally horrendously expensive. And so what I did instead, and let's go over to Visual Studio. What I have instead is an application I wrote that uses a binary image from KO4BB, where somebody had uploaded a copy of the memory from their mass memory module to the website. So what I can do is go into the mass memory module and extract the stored functions and then reprogram the system. Now, to do that, you had to decode the actual memory setup, because it's just a straight read all the way through. So a great user on the EV blog, Kirill Carr, went and did that work to decode the address lines and how they actually map to a normal straight single memory page. And that enables me to go through and extract all of the DLPs from the ROM, and then I can actually push them back into the ROM, into the mass memory module, and we can then go and install them. So let's actually have the look at the utility running. I have it already running here. So I can set the GPIB address. This doesn't actually work yet. Still have to implement it. There's some to-dos in the code if you want to take a look at it. It's on my GitHub. I'll publish a link in the description. Anyway, I can read the ROM. So it's going to go grab that, and it said it found 278 individual function definitions. Let me clear the mass memory, and so we'll go yes. And if we just jump over here quickly, you can see on my 8563, if I have a look at, let me go back to local, look at module, utility, you see that we have no apps installed on it. There's nothing up the sleeve. So let's flip back to the app, And what I'm going to do is I'm going to go and create the DLPs. Now we're just going through reading the string set and pushing them out to that utility. Now while that's going on, let's go back to Acrobat quickly, and we can take a look at a photo. I finally picked up all the bits and pieces of the dumpster score. So what we have here are three 3335As. There's actually four, but I had one inside. I don't know what that is. I'd have to go have a look at that. There's two 33-250s, a shunt. I think it's a 400 EL. There are two 8663As, a 3585A, and a DSO 8104A. Now, all four of the 3335As work. Would they meet calibration? Probably not. The two 33-250s both failed calibration, and I have the cal docs, or some parts of the cal docs. I don't know what they failed on, but we can go look at that. This guy has a broken wire, and it just needs, I think, to be soldered back in, and then it should be good to go. I don't know about that analog meter. The two 8663As just aged out. Don't think there's anything wrong with them. There was no information about them being wrong, just not calibrated. The 3585A doesn't display a signal. I don't know if that's the CRT's dead or the whole unit's dead. And I do know that the DSO 8104A won't turn on, so that could be a power supply issue or something like that. Anyway, we'll take a look at all those things from the dumpster as the next few weeks come out. Okay, so we've done pushing the parts there. So let's go back to my Spectrum Analyzer and we'll take a quick look. So we'll go back to local control, we'll go to module, let's have a look at utility, and there you go. You can see that we have all of the utilities there. Now, we have to run the setup programs to push them to the actual units. So let's go, before we do that though, what I'm going to go do is I have a signal coming in. So let's set it. It's coming from my raw goal. I think it's a DG 1032Z. Anyway, let's set the start frequency to that to say 5 megahertz. The stop frequency, we're going to say 50 megahertz. And there you go. You can see the signal. It should be, if I did a peak search, it's going to be 10 meg signal at around 0 dBm. There's a long BNC cable, blah, blah, blah. Okay, so now let's go back to the module. We'll go to key defs. I'm going to choose a DLP, and I'm going to find pH setup. There we go. So this is going to set up the phase utility. I'm going to select execute now, and we'll stick it on key 1 and key 2. Great, we'll go back to module. We'll go to key def again. We'll choose a DLP, and we'll step through the page until we get to SP setup. I think it's one more. There we go. Okay. And I don't know why. Anyway, I don't know why it seems to go the wrong way when you do the rotary encoder. Anyway, now it should give me an option to stick it on here. Okay, so now that we have that running, what we can do is we can just measure the spurs. So let's measure the harmonics first. We don't have to do anything because everything's already set up. So let's just measure those harmonics. And you can see the system is now running under control of the utility, measuring the harmonics for that signal. The drink of choice today is a coffee inside my Seahawks mug. And there you go, you can see that we've run the levels of the stuff there and come out with about a 0.1% harmonic distortion, and you can see all the harmonics there. So what we can do is go back and say, well, let's have a look at just all the spurs, and we can configure how we're going to search for that. So we're going to say the minimum search frequency is going to be 1 megahertz. The maximum search frequency is going to be 100 megahertz. I'm going to want to find every spur that's above say 80 minus 85 dB. So now we're going to go and say let's done, and it's going to work out how long do you think it's going to take me to do that search. So it'll take about a minute. Okay, so let's go back. It's a bit too long. Let's change the lower threshold to minus 80 dBm, and then config done. And we have 14 seconds. That's much better. So let's go measure those spurs. And here's our spur line. We can see it's finding all the spurs that are above that line. And then it's going to go measure them. And there are our spurs put up. So that's just a quick example of the apps running and how you can do DLPs. And now you could program your own DLPs and push them across using the same method. I hope you found that interesting, and we'll be back soon with more repair of the SR560. Anyway, catch you later. Bye.